And as is usually the case, we can transfer all of these tests to proportions, assuming that we use a normal approximation to the binomial distribution. So we'll just do one example here. It should highlight everything you need to know. There's a proportion of recaptured moths in the light-colored population, P1, and the proportion of recaptured moths in dark-colored populations. So the way you run the experiment, you capture a moth, you mark it, you let it free, you wait a little bit, then you go about capturing more moths, and you're going to take note of which ones you've captured twice. That's going to help you provide an estimate for the population size as a whole. So these capture-recapture experiments are usually used to try to figure out how large the population is, given that we don't have access to all of the moths. In this case here, we know what the populations were. We had 137 light-colored moths, and we had 493 dark-colored moths. So we run through the capture-recapture experiment. 18 were recaptured for the first population, the light-colored moths, and then 131 were recaptured in the second population, the dark-colored moths. Is there actually a significant difference between the proportion of recaptured moths in both populations? That would suggest then that there are differences in the populations, either in terms of their sizes, their true sizes, in the wild, I mean, as opposed to in the first population that we had, or potentially that, dark-colored moths are easier to see and so easier to catch a second time. At any rate, we are testing here for the null hypothesis that there is no difference in the proportion of recaptured moths in both populations against the alternative that there is a difference. And here we're going to test for P1 being different than P2, not P1 being larger than P2 or P2 being larger than P1, just being different. We need the observed proportions. We know what they are. The number of recaptured moths in the first population was 18 out of 137. It's about 13%. And the number of recaptured moths in the second population was 131 out of about 500. That's roughly speaking 27%. The difference in the proportions, P1 minus P2, the observed proportions, I should say, is minus 0.135. The corresponding p-value for the alternative, given that we are looking at the alternative that P1 is not equal to P2, would be twice the probability that P1 minus P2 should be smaller than minus 0.135. And then if you work it out by using the normal approximation to the binomial distribution, you're really interested in computing twice the probability that this standardized value would be smaller than this value. And that's going to get you, roughly speaking, Z being smaller than minus 3.20 times, which is very nearly zero. And so you would reject the null hypothesis here at both the 5% confidence level or the 1% confidence level. One thing to notice in here is that you need to have some sort of variance to put in here, some pooled variance. Well, it's actually the pooled proportion that you need in order to be able to compute this pooled variance. You need to know what p hat would actually be, not the proportion in the first population and the proportion in the second population, but the proportion in both populations, so to speak. It's a weighted proportion based on the fact that you have a different sample size in both populations. So this pooled proportion of recapture is about 24%, 23.65. That's the value that goes in there in order to compute this quantity, minus 3.1.